All right, in this video, we're going to continue on with our unit on trigonometry, and today talk about solving right triangles. So to solve a right triangle, what we mean is find all the missing pieces. So we all know a triangle has 3 side lengths and 3 angle measurements. Well, since we're going to be talking about specifically right triangles, you already have one piece to the puzzle right away, the right angle. So one angle is always going to be 90 degrees. A key fact to remember about angles in any triangle, no matter the size or shape, is that all 3 angles will sum or add up to 180 degrees. So let's think about that. Relate that, apply that to a right triangle. One of the 3 angles is already 90 degrees, so how much is left? All right, so that means the other 2, we call them acute angles, have to add up to 90 degrees. If you remember back to geometry, there's a word for 2 angles that add up to 90 degrees. Complementary. So if the right angle is 90 degrees, the other 2 angles, which are both going to be acute in the end, less than 90, wind up being complementary because they also add up to 90 degrees. In the end, again, all 3 add up to 180 degrees. So a couple of things to note about this first example. The first thing we want to note is how the picture's labeled. And I mean by the ABCs that you see around the edges. The capital letters A, B, and C are the angles, and it's not a coincidence that if you look opposite each angle, you're going to see the same lowercase letter on that side length. So angle A is opposite side length A, angle B is opposite side length B, and angle C is opposite side length C. Typically, the right angle is the angle C, because then across from it or opposite it is the hypotenuse, which is most commonly labeled as C. You can think back to your Pythagorean theorem, a squared plus b squared equals c squared, something we'll use today as well. So what you can do first is take the given information from the picture, and we like to provide you guys with this organized way of reporting your answer. And there are some answers that all you have to do is take them from the picture and place them in the table where they belong. So the measure of angle C, there's no number there, but that little box means 90 degrees. And angle A is 28 degrees. And side length B, we're going to call it, is 15 units. We'll just put 15. The units aren't necessary unless they're on the picture or given to you in the problem. Now, try to approach this in the easiest way possible. If you look at the table or the picture, kind of look at the 3 pieces of information that are missing, and it's always going to be 3 pieces that are missing that you have to fill in. You're always going to know that one of the angles is a right angle, and you'll either be told 2 side lengths or 1 angle and 1 side length. So here's the case for this one. 1 angle and 1 side length is given to us. The easiest thing for us to do in this case is to find the missing angle B first, just by subtracting. All right, so you can think about it as A, B, and C. Those angles have to all add up to 180, or you can think A and B, both of the acute angles, just have to add up to 90. So that would leave us with a difference of, not 68, 62 degrees for angle B. Now, to find the lengths of side A and side C, we are unable at this point in time to use Pythagorean theorem because we have 2 missing side lengths. So what we have to do first is actually use trig to find either A or C first. And then we could proceed with Pythagorean theorem from there. Well, we could do 2 different ways from there. We'll look at those when we get there. So let's just go with, let's find letter A, that side length first. So I'll highlight that on the picture. All right, so what I like to do is look at the acute angle that's given to you. The acute angle given to us is angle A, 28 degrees. I'll mark that with a little star. And since we're going to use trig, we need to know how the sides refer back to that angle, that reference angle. So where the 28 degrees is located, side A is opposite, And we're not going to use side C, the hypotenuse, because that's a second unknown. We're going to use 15 because we need another number that we know. We can only solve an equation for one unknown, and right now side A is the unknown. So side B of 15 units is adjacent to the 28 degrees. So let's think about our SOHCAHTOA and decide if we are in a position of using an opposite and adjacent side. Okay, that's going to be not sine, but opposite and adjacent, not cosine. It's going to look like tangent. So we're going to set up a tangent equation here. And when you set up the equation, inside the parentheses is where the angle measurement we refer back to belongs. So 28 equals, on the other side, OA, okay, that tells us the order that we input the parts into the fraction. So the opposite goes on top, A, and then the adjacent goes on the bottom, 15. From here, think of this just as an Algebra 1 equation. Do anything you have to in order to solve or isolate the variable, A. In this case, to do that, we just have to multiply by the denominator on both sides so that we keep the equation balanced. So I'm going to go over to Desmos here and figure out what 15 times the tangent of 28 is. All right, now it's important when you open Desmos, you go to this wrench over here. And since we're using trig, we need to make sure that the settings are set to degree mode. And this is going to be true even if you're using a handheld calculator. If it's the case of a handheld calculator, find the mode button and make sure you have highlighted degrees instead of what's called radians. These are two different ways to measure an angle, and in calculus, the trigonometry we're doing now, we're going to use degrees. When you get further into calculus, you start using radians. So now that I'm in degrees, I can close that, go to my first line, forget what I have to type in. So 15 times the tangent of 28. So I can do 15 times, I'm going to go to functions, tangent, 28, and you can see that it's there. Let's see, are there any directions for rounding? I don't think so. Usually I say thousandths, so let's do 3 decimal places, 7.976. 7.976, and units don't matter in this case, they're not given to you. So that is what A winds up being in length. Awesome. So what we're left with is we just have to solve for length of side C. Okay, so to do this, there's 2 different ways. To solve for the length of side C, you can do something similar to what we just did. You can go back and instead of using side A, because we were trying to solve for side A before, we can actually use, if C is what we want to solve for, label that as the side that it is, the hypotenuse. And if you're looking at SOHCAHTOA, this time you would use, instead of tangent, hypotenuse and adjacent. Hypotenuse and adjacent come from cosine. So you could say the cosine of 28 equals adjacent 15 over hypotenuse, or letter C, because that's what we're trying to solve for. And then solve this like you would an Algebra 1 equation. Well, if you notice where the variable is, this one's actually going to take us 2 steps to solve, because we have to split up the fraction, first by multiplying by C on both sides. But you'll notice that all that does is move the letter C to the left side. Okay, so let's kind of write out what we have then. So what we'll have is the cosine of 28 times C equals 15. So then you still have to get that C by itself by dividing both sides, because you want to keep it balanced, by the cosine of 28. So then what we're going to do is type into our calculators 15 divided by the cosine of 28. Enter 15 divided by cosine of 28. Now let's do 3 decimal places again, 16.989. 16.989. Now, if you're not as comfortable solving that trig equation, or you'd rather not have to solve 2 trig equations, you could solve the first equation using trig. There's no way around it, so you'd have to do the tangent equation first. But what you could do is, if you trust yourself enough that you got that answer correct, you could use what you got for A and what you were given for B to solve for C using Pythagorean theorem. I tend to not suggest you do that, because say you get the answer for A incorrect and then you use it to solve for C, you're also going to get C incorrect. So you're a little bit safer just going the route of what we just did, doing 2 separate trig equations.